Hey guys, good afternoon. John Hominack here with the latest storm chasing report. A briefing on the upcoming severe weather event, which is forecast for Sunday, February 26th, 2023. Before we get started, just a quick thank you to everyone for the feedback on the video earlier this week and for following, joining, subscribing with the channel. Super excited to do these for the rest of the year with each of the events, and obviously when we're out on the road, some live streaming, video, things like that, going to be really fun. But the forecasting aspect of this, to me, is going to be a cool part of this channel as well. Not just videos of tornadoes or things like that, but also the forecasting thought process that goes into all of this. So really excited for that and excited for this first one coming up here on Sunday. So the Storm Prediction Center has outlined an enhanced risk on Sunday. You can see that here, just zooming into the south central plains, looking at that risk area extending from far northeast Texas, parts of the Panhandle, really kind of near Childress, off to the north and east into central Oklahoma. And this includes a 30% combined probabilistic enhanced risk. So as we get into the day 2 outlook tonight, we should probably get a better idea as to what the Storm Prediction Center is thinking here, but this does a great job of outlining the overall threat area for this event. So going back to the synoptics, we are in firmly in deterministic model range now, where we can use these models with a little bit more confidence and get an idea as to where this event might be heading. So we're looking at the European model here and taking us into Sunday morning, and obviously the first thing that sticks out is a very intense, compact, but intense and amplified mid-level jet, with the European itself indicating that on Sunday at 21Z, this will be a 138 knot mid-level jet, which is ridiculous. Obviously very, very strong, powerful jet coming out of New Mexico into the Texas Panhandle and eventually into the south central plains. So this is a big-time jet for any time of year, but here in late February, when we'll probably have at least some sort of moisture and instability to work with, it obviously becomes more significant from a severe weather perspective. It also is going to elicit a very notable mass response. So we see this jet stream coming out of the Four Corners, and we notice very quickly Sunday afternoon already by 21Z, we have an impressive low-level jet in place across the southern plains. This is a 50 to 60 knot south-southwesterly low-level jet by 21Z Sunday. And then by 0Z, this increases to 70 to 75 knots in both the eastern Texas Panhandle and northeast Texas and Oklahoma, all the way up into Kansas. So this is obviously a very, very impressive signal from a low-level jet perspective. And when you combine it with what we're seeing even in the mid-levels here, if we go back to the 500 winds, you have your 500 wind oriented like this, and then you have your 800 winds oriented like this. So your wind shear signal is obviously quite strong with this system as well. Just a quick look at the upper level jet, and even that is pretty impressive. Your 300 millibar jet coming in here at 21Z into parts of the Texas Panhandle as well. So all this is to say, this is an impressive disturbance coming in. Now to the elephant in the room, which is something that we've seen a lot of on social media now over the last couple days, and there's been a lot of really good discussion about, is our moisture return. And so just looking at the European and going back to kind of where we stand here as of today, it's clear that the moisture return is going to be a last minute thing with this system. At the moment, as we head into Saturday morning, and as it stands right now, there is a deep Arctic high centered across the northern plains, a 1044 high over the eastern South Dakota and Minnesota. So this is a huge area of high pressure in place as of Friday. So this will eventually, fairly quickly, move on off to be centered in New England by Saturday morning. This is valid at 3 a.m. on Saturday. So the center of your high pressure is now over here in New England, but you are holding on to some low-level cold and high pressure down into the central and southern plains. And you see that reflected in what the European model is suggesting from a temperature perspective. Even here at 10 o'clock a.m. on Saturday, we still have some pretty decent low-level cold kind of meandering down in that region. So the day before air mass is not going to be very classic in this setup, just from the perspective of kind of any warmth or moisture just hanging out the day before. It's going to be cold. There's going to be cold lingering even into Sunday morning. This is valid on Sunday morning now. So again, as we head to later Saturday into Sunday, that high pressure will begin to pull out. But the model data begins to split at that point in regards to how this moisture return will occur. Some of this has to do with how far south our frontal boundary gets, which we see the European model suggests will be somewhere around here. But a lot of it also has to do with the cyclogenesis that begins to occur here and the mass response that it elicits. And I think that's a lot of the differences that we're seeing between the European and the NAM model, for instance. That's been a big focus, is why is the NAM model so much drier? And one of the reasons is because of the mass response that it's eliciting from this storm system. So zooming in, getting into a little more of the nitty-gritty details, just to give you a comparison between the European and the NAM. Obviously, the NAM model is much, much slower to scour out these colder temperatures and lower dew points. This is valid 9 o'clock p.m. Saturday night. And I'll flip back over to the European model here, and you see you already have better quality moisture up here into central Texas on the European when you compare that to the NAM, which at that time has much less impressive moisture. Your frontal boundary is way down south here. So there's a couple things to go through here. Obviously, the NAM can be a useful tool when it comes to your surface temperatures, especially those shallow, low-level cold air masses. But often this time of year, there's also an argument to be made that it can be too cold. It can be too stubborn to remove the cold and allow things to warm up. And so both of those things need to be factored in here. If you look at the last couple model runs of the NAM, and I want to back up and just look at the run-to-run change here, you'll notice that on Saturday morning, the NAM has been getting a little bit warmer. So this is one thing to keep in mind, right? The last couple model runs, it's warmed up a bit across central Texas. And the European, at the same time, if we go look at that, it's cooled down a bit across central Texas. So the models likely are going to eventually come to a point where they meet in the middle. And that kind of lets me lean back on the ensembles at this point, right? Because obviously the moisture return that we get with this system is going to be critical. If you look at what the European model suggests will happen, the moisture begins really returning on Sunday morning, and we have strong warm air advection ongoing here into this system. We talked about that mass response, right? That's helping this all out. That's one thing you can put in the bucket of reasoning as to why the moisture should arrive. The European model brings the moisture up, and by the time we get to 19Z on Sunday, we have a 61-degree dew point at Childress, which is obviously quite impressive for this time of year. And you can see the moisture still advecting northward into Oklahoma Sunday afternoon. So the mass response is occurring, it's happening, and the system is, you're kind of set up at this point for severe storms if you believe the European model. The NAM model, on the other hand, in a different camp. It's much further south. It's much slower to build this moisture up. You can see it starting to make that happen. But again, that mass response, the cyclogenesis, it's all part of drawing that moisture in. And the NAM is just in a different camp right now when it comes to how that's going to go. So for the purposes of this discussion, we're going to use a blend of all the models. We're going to lean on the European model, the European ensemble, and the GFS. And we'll factor in a little bit of the NAM and kind of keep that idea in mind that maybe the Euro and GFS and the ensemble guidance that goes along with them are a little too aggressive with this moisture return. We'll keep that in mind moving forward. So let's get into the nitty-gritty details of this, right? Again, here's the European model. This is valid on Saturday. You see that low-level cold kind of bleeding down and hanging out as we go through. But now to roll through to Sunday morning, and we see that we now have that low-level moisture returning back up. So what happens by the time we get to the afternoon? Well, you start to see these 60s dew points pooling northward. The southerly flow is really drawing them up. And by the time we get to 21Z, now things are starting to sharpen up, right? If you look at, I'm going to zoom us out here and take us back to the central U.S. sector. But if you look at this setup overall, you'd like a little bit of a tighter dry line and circulation. But overall, you have ample moisture, south-southeasterly flow building in here, and a signal for the development of a cyclone here in eastern Colorado with a trailing sort of secondary low pressure developing here down into Kansas and the northern Texas panhandle. And so the European model suggests that we'll start to see isolated to scattered convective development during this time frame. This is valid 21Z on Sunday. And so again, now it becomes important to look at what quality of the moisture and instability is. We know that the European suggests that it will be pretty good, but if we go and look just for the sake of argument at the instability parameters. Here's your Cape axis right here along this dry line on the European. There's also some extending up into Kansas. But if we want to take a real look at how this looks on the dry line, along the dry line initiation area, just to take a look at a sounding, we can see a couple things. First of all, we're still slightly capped, so we're probably not going to get convective development immediately here. But these are not bad wind profiles, especially for the Texas Panhandle, right? We see a lot of curvature. We see these winds backing to southerly in the lower levels, and a decent hodograph to support the possibility of discrete convection, our vectors and wind fields supporting discrete thunderstorm development. So by and large, the European model suggests here, just looking at it from a very broad overview, that we would see convective development likely beginning during late afternoon hours in this general vicinity here in the northeast Texas Panhandle, possibly into northwest Oklahoma, southwest Kansas, and then shifting off to the north and east rather quickly at that time. Looking at the synoptics again, this is a very, very impressive mid-level trough coming into this region. So there's a lot of things that need to be factored into this forecast. First of all, anytime you're dealing with this kind of dynamics, these storms are going to be moving very quickly. So that's one thing you want to factor in as a chaser. But the other thing is thinking about your storm mode, right? Because what's the forcing look like with this trough moving in? This is valid at 21Z again. And if this is your initiation area right here, you have very, very strong forcing that's right on the doorstep of this storm system. So I want to flip back over really quickly here to the southern plains. And let's make the assumption that at 21Z, we have this ample moisture, we have this instability to work with, and we have the wind fields that are fairly favorable. We have our thunderstorm development. Using the wind profiles that we were just looking at, the thunderstorm development should be initially, at least partially discrete in this general vicinity. This is a good wind profile for supercells. And so the European model showing that overall sort of convective development to me is not necessarily surprising. As we get closer to 0Z, you start to see more convection popping up, and that's not necessarily surprising because your very strong forcing is moving into the panhandle as a 126 knot mid-level jet. And even if we look at this from a vorticity perspective, and I love, I think obviously that provides us with a better look, we now have a very, very impressive look here to the overall jet dynamics. And it's likely that as we get further into the evening, the support for discrete convection is going to wane fairly quickly. And that's something that we want to keep in mind as well. So let's reset here for a moment. Obviously, very strong disturbance coming in, very strong mass response. We have some moisture concerns, but overall, we're going to currently lean towards the European model, include a little bit of the NAM, but lean towards the European model, and likely continue with the suggestion that we're going to get enough moisture to get strong to severe thunderstorm development. Let's go back here really quickly, and I just want to pull up the GFS model because I thought it offered a good view as to how this might evolve. So if we look at where we are here at 21Z and 22Z, there's a couple things happening. And I'm going to zoom in here to Texas because I think it offers a really good view as to this from a chasing perspective. So we're going to make the assumption that we're going to have thunderstorm development in this general vicinity here during the late afternoon to early evening hours. We have very particularly here on the GFS a very clear dry line and then a very clear frontal boundary. This frontal boundary is sweeping in quickly. But you'll notice the separation between the two, right? Even backing up a couple hours. Here's your true cold front, and here's your sharpening dry line right here. That's unusual this time of year, especially with such a strongly forced event. A lot of times, the front is almost right on top of things, and by the time that front hits, all that forcing hits as well, and you get a QLCS or a line of storms. From a discrete supercell, photogenic, tornado potential, I think there is a window here if we do get this moisture return where you could have storms developing along the dry line that aren't yet overtaken by this front. And I think that's important because your wind fields will support that discrete convection and those supercells to move to the north and east and remain in good moisture quality ahead of this cold front, at least initially. I think that's a really important distinction. If we look at the GFS here, we watch this convective development. This is just an example. Obviously, don't take this face value. But we do have a storm that develops, or multiple storms that develop in this general environment. And again, they are ahead of the cold front, right? As you get closer to 7, 8 o'clock, the frontal boundary begins to catch up with this dry line. And when that happens, all bets are off, because your front is likely going to undercut your storms, and you're going to, look at a more linear sort of QLCS type event, which we'll get into in a moment. But to summarize, I'm going to go back up here a little bit towards Oklahoma. To summarize, there is, as modeled right now, going to be a window here where we could get thunderstorms to develop in an environment that is fairly favorable for discrete supercells. And we could see, and this is a very, very big could, we could see these storms obviously be somewhat photogenic and produce all severe weather hazards before that front catches up. Again, we have very, very, very impressive dynamics to work with here. I think the window will be somewhat short, but the window is there in this general vicinity for those storms to form if the moisture's there and the timing is right. Now, let's take a look at a sounding again, because I want to just note a couple things from a chasing perspective that are going to be important. I'm going to flip over to the latest GFS model here and use this as an example. So, utilizing the latest GFS, let's look at what it shows at, valid at 0Z, right? So here's an example, GFS model, 0Z, Western Oklahoma. The one thing that sticks out to me here when we look at this profile is obviously this is a supercell wind profile, ample moisture with dew points approaching 60. But the storm speeds in particular are something that need to be noted. These are going to be moving quickly. And from a chasing perspective, it may not be the easiest thing to keep up with these storms. They may be moving fairly quick off to the north and east. You may have to adjust rapidly, and you may have to pick your storm and go for it very, very quickly and make your decisions. Because again, the window is short, the storms are moving fast. It's not necessarily going to be an easy chase. So again, just to summarize from a chasing perspective, your discrete supercell potential for me is between 21Z-ish and 0Z. It's right in this general vicinity of northwestern Oklahoma. It's a very, very impressive supercell wind profile. Maybe the eastern Texas Panhandle as well into western Oklahoma. And your residence time is probably about 1 to 2 hours before that frontal boundary catches up. Now, we know we have an impressive low-level jet coming into this as well. The European model really ramps that low-level jet up. We see the mass response occur here, right? It starts, this is valid at 21Z, so we already have an impressive LLJ. Then as we move closer to 0Z and then 3Z, it obviously becomes even more impressive. This is a very strong low-level jet. We know we have a very powerful 500 millibar disturbance coming through as well. And so the end result of this for me is likely going to be the development of a severe wind threat with this system as well. Flipping back to the European model and looking at how it evolves this entire system here through the evening in Oklahoma, if you pull up these soundings a little bit closer to 0 or 3Z, let me go back to 0Z here, and you pull up at how it looks in this general vicinity ahead of the convection, you get not only longer, wider hodographs, but you still get supercell wind profiles. And again, factoring in kind of the upper level winds and then the low level wind speeds increasing from 0 to 3Z with this very, very impressive low level jet development, I think it's clear that in addition to that initial discrete thunderstorm threat here in the eastern panhandle and western Oklahoma, what we're eventually going to get here is a very, very impressive wind event with severe thunderstorms possibly producing significant wind as they move through central Oklahoma, possibly even parts of southern Kansas Sunday night into Monday. I wanted to take a moment to look at some of the machine learning guidance. I love using this CSU machine learning product. It does a great job overall with these events. And looking at the individual hazards here, the focus again on your tornado potential pretty much lines up with our synoptic discussion, the area that we thought it would be. And then we obviously have our wind potential and then our hail potential as well. The hail potential, I think, is going to depend on how severe these storms are initially, the isolated severe thunderstorms that do develop in the eastern panhandle and western Oklahoma before the wind event takes over. If we look at this from an aggregate overview, which they also offer here on the day 3, in addition to the individual hazards, we can see that it matches up fairly well with the Storm Prediction Center forecast. So this is the 12Z run. This is the SPC forecast issued last night. Pretty much a dead match to the latest CSU, and you could see where they're simulating the best chances for severe weather in general. So again, looking at this overall threat, this is a potentially significant severe weather day. If you are storm chasing, I think you want to be on these storms early. You want to be there for the dry line development. You're hoping that this moisture does get there. Obviously, at the moment, I'm leaning closer to the European than I am the NAM. Factoring in the NAM a little bit, though. I don't think it's wise to totally ignore it. You want to factor it in. But the likelihood is there for possibly 1 to 2 hours of discrete thunderstorm potential in the far northeastern Texas Panhandle and western Oklahoma. If this does move a little bit south, you would look a little bit more like this. But anyway, this is your area where you're looking at 1 to 2 hours of residence time of potentially discrete or semi-discrete convection before that Pacific front catches up. Once that front hits, it's off to the races with this wind event, and the low-level jet really, really ramps up very quickly into the overnight hours. And I think it's distinctly possible that this turns into a significant wind event for parts of western and north central Oklahoma moving into the late evening hours of Sunday and then early Monday morning. So if you are chasing, good luck, get out there. This is meant to be sort of an overall guide for storm chasers, not necessarily for meteorology in terms of how you should prepare if you're a resident. But if you are a resident, keep all this stuff in mind. Know that the possibility exists for discrete supercells capable of producing all hazards in the northeast Texas Panhandle and western Oklahoma, and then that severe wind event possibility in the western and north central Oklahoma Sunday night into Monday. From a chasing perspective, I do think the window for photogenic discrete stuff is pretty small here, but it is worth a trip out for this, at least for me, based on the latest observations and the latest data. I think this looks like a good early season small window chase to possibly get something good in this time frame. And the tornado potential obviously will be there as well before this all congeals into a more significant and substantial wind event Sunday night. I'll be back with more updates, heading out to chase this one, obviously. And we'll be here throughout the weekend providing updates on the latest data. Whether it's good or bad for storms, we'll be here talking about it. Thank you guys again for following, for watching, for checking it out, and I'll talk to you tomorrow. Have a great Friday night, guys. Take care.